Good afternoon, I'm David Thomas. I'm the Executive Director of the Milo Institute at Arizona State University. Thank you for joining us at this Global Network Forum. Today we have a panel of distinguished individuals, and we're going to be talking about a very interesting topic. This is around infrastructure, and if you think about sort of what's happening over the course of the next few years, NASA's Artemis program is driving a tremendous amount of infrastructure development for the moon. You have companies like Lockheed Martin that are developing satellites that are going to provide communication and navigation. You have SpaceX and Blue Origin that are going to be developing fuel repositories on the moon as part of human landing systems. All of these bits of infrastructure create opportunities for new players and new participants in new ways. So we can think of commercial services that allow perhaps those players that may not have space heritage to participate. We can think of new ways of doing scientific research, new business models, and so I believe this is going to be a fascinating conversation. So please join me in welcoming our panelists to the stage. So I'm going to provide, each one is going to provide a few minutes of introduction. I'm going to ask questions. I want to encourage everyone to please use the Slido app. I'll weave in some of your questions as well. And so with that, I will turn it over to AC Trania. Sir, your introduction.
All right. Thank you, Dave. Welcome to IAC 2023. I think I was looking back, this might be my 17th or 18th IAC, so always happy to join our friends around the planet here every year. A little bit about me and a little bit about what I'm doing at NASA. So a little bit about my personal and professional history to get to this stage. Grew up in Atlanta, Georgia, and went to the Georgia Institute of Technology, so Georgia Tech. And since that time have been involved for 23 years in terms of commercial space and aviation prior to coming to NASA. That journey included working at a startup based in Atlanta and then Washington, D.C. for about 12 years, where we did a lot of advanced concepts, systems analysis for NASA, DARPA, Air Force, commercial space entities. I was also proud in that experience to do collaborative space projects with companies in Japan and South Korea. And that has guided my interest in international collaborations to this day. In 2012, I joined Virgin Galactic, as some of you may know, and I was on the initial team that formed the Launcher One program, which eventually became Virgin Orbit. So was involved in strategy, business development, advanced concepts. Me, the chief engineer at Virgin Galactic, were given a special mission by then our boss Steve Isakowitz to go look at an alternate aircraft for the Launcher One program, which ended up in us selecting the 747-400. So yes, I have bought a 747-400 in my career and put a left wing on a rocket on the left wing. So that was an incredible journey. Was also involved in the OneWeb, the discussions between Virgin Galactic and OneWeb for a multi-launch contract. And from that experience then went to Blue Origin. And so when I joined Blue Origin in 2017, they basically said, hey, we're starting a lunar lander program, here you go. It was me and two engineers. So we kicked off an entire 5-year journey that resulted in technology demonstrations using New Shepard and NASA landing sensors, to multiple studies in collaboration with NASA, to working hand in hand and maturing rocket engine technology with NASA Marshall, to then forming the national team with Lockheed Martin, Northrop Grumman, and Draper for the initial human landing system base period performance. So we won $500 million from NASA to mature that crewed lander mission. And then subsequently the reformulation of the lunar lander program at Blue Origin into the lunar permanence program, and then into the current architecture that they have today. Then in 2022, went to an aviation startup called Reliable Robotics, and that was kind of rounding up my space experience with an aviation kind of autonomy company, where that company was trying to modify existing aircraft to fly automated for all the world's cargo carriers. So a very interesting experience in space and aviation, in early part of technology infusion. I probably have been involved in probably 50 plus projects, studies that have gone from the back of an envelope to PDR, and then some have continued on to CDR. So that has been my professional experience of getting things matured to a certain phase. Now at NASA, coming into NASA, I think the agency wanted to think and leverage these experiences in commercial public-private partnerships, and that's why I think I came into the agency. And so my mandate at NASA headquarters is to support our administrative suite, or A suite as we call it. So the A suite at NASA consists of our top 3 leaders, Administrator Bill Nelson, Deputy Administrator Pam Melroy, and Associate Administrator Bob Cabana. So those are my 3 leaders that our office in the Office of Technology Policy and Strategy support, kind of as the headspace for our senior leaders. So we tackle problems that are across directorate, tackles problems that are interagency, problems that may include international collaborations for our senior leaders. And the power I have at NASA is not a large budget, it is not a large team. What I do have is a very powerful spotlight. And what I can do is for our senior leaders, spotlight gaps, issues, problems, and help coordinate different technologies ranging from quantum to AI to other technologies that span across our directorates. So it's a pretty interesting position, and I'm looking at how the agency can innovate better in early stage technologies, how we can think about some of the emerging technologies like quantum and AI, and how do we also think about, as we have a panel later this week on technology infusion, and that's another intellectual problem I'm trying to think about. Of we are maturing all these technologies within various parts of NASA, but how do our missions use it? So the panel before us, Jim Free from NASA, who runs our Exploration Systems Mission Directorate, was talking about the Artemis program. So I try to think about how are the technologies we're investing in now support Jim, support Artemis, to enable us to make Artemis different than Apollo, to be able to have more sustained lunar exploration. And those are the kind of intellectual problems I try to wrestle with. And the tools I have are early stage innovation, investment, collaborations with other government agencies, collaborations with commercial industry, and international collaborations. So, thanks.
Thank you, AC. Aude Beniel is the Chief Technology Officer for the Australian Space Agency. Aude, we look forward to your introduction.
Thank you, and thank you for having me here. The Australian Space Agency is still very young. We just celebrated our 5th anniversary, but despite that, we can already see the outcomes of the investment we've done across several projects. We have 60 projects under our belt just now, some still going. Project small, projects big, but it's very good to see the outcome and impact we're having on the industry in Australia. In our role in the Office of the CTO, we are assessing the space capability of Australia. We are looking at the opportunity for this capability to grow. We're scoping project and program for helping this capability to fulfill their potential, and we're delivering this program. These programs and projects are across several disciplines, PNT, comms, space medicine, but one I would like to focus on today is around our off-Earth opportunity, which are rising. As you know, in Australia, we have been operating large-scale operation from remote location. I will always remember the first time I visited a Rio Tinto Mission Control Center in Perth. I had the impression to enter in a mini Houston type of mission control, because there was a great focus and concentration in that room. There were different pods dealing with different activities. I approached the pods of drilling, and I was talking with a lady who was doing this drilling operation, and she was doing some drilling operation located 2,000 kilometers away in the Pilbara region. She was using communication link through geo satellites, so the user interface that she was using was catering for the delay that this entailed. And when you look at this expertise of doing this kind of remote operation, this is what we try to capture in this top right picture behind me. This capability we have on the ground, how can we export that in space? what can we learn in space to make this operation more efficient, more sustainable, and how can we spin back this learning back on Earth. So this is what we're concentrating on just now in Australia when we're talking about deep space exploration. Next slide, please. And we have put in place a Moon to Mars initiative along 3 pillars. A supply chain is really looking at the capability we have with some terrestrial products. We're helping this industry to make these products space qualified so they can enter the space supply chain ecosystem. We have a demonstrator project where we are looking into helping industry to do at the end-to-end life cycle of a space project from feasibility up to operation. We have 20 projects happening around this initiative. And last but not least, we have our Trailblazer program, which is our rover to the moon. Next, please. As I said, I'm not going to talk about the 60 projects we are doing, but I just want to take 2 seconds on 3 of them. Advanced Navigation is developing some innovative inertial navigation systems. One of them is going to be on board the Intuitive Machine missions that should be launched before the end of the year. Could be the first Australian tech landing on the moon, so we are very excited about that. Fleet has developed a geodes who help measure the seismic noise in such a way that they can build a 3D model of underground and see where interesting resources are and what type of resource they are. We are looking into miniaturize these geodes so that we could maybe deploy that on the moon because that would be a great way to look for resources on the moon in a non-invasive manner. And Skycraft has designed an interesting pizza box-shaped CubeSat, or actually satellites, and they're deploying a constellation around Earth to help with air traffic management services. Next, please. And then this is our boldest adventure yet, our rover. So we will launch this with NASA. We're going to piggy ride a ride with the NASA CLEPS. We have currently 2 consortia competing to deliver a prototype, and at PDR will we down select to 1, which will be the happy winner to launch that rover on the moon to demonstrate this remote operation capability I was talking about. Next, very quickly, the previous panel was talking about the 4 Moon to Mars objective and that NASA has explained in several documents. So the 60 projects, we map them against these 4 objectives, and we also add the TRL level of each of these projects because 5 years old we are, but some of these TRL are 9, so we are already able to support today some of the niche services there. And the last slide was to show the infrastructure that you have all across Australia to support deep space exploration. It goes from test centers, optical ground station, research center to develop plant for space. There is lots of information in there, but we're going to put all that on our website. So this is what we are looking at developing and promoting for supporting space exploration.
Thank you, Aude. Next, we have Dan Shears. Dan is a University of Colorado Distinguished Professor and the A. Richard Seabass Chair in Aerospace Engineering Sciences at the University of Colorado Boulder. Dan?
Thanks, Dave, and thanks very much for coming. First, I'll just say a few words, and I just have a couple of slides. I'm coming at this from a slightly different perspective. I've been on the science side and a bit on the engineering side for over 30 years, with my focus mainly being on asteroid missions. So I was a member of the NEAR mission, the first rendezvous mission with an asteroid, and I've been involved with the Hayabusa missions, Hayabusa and Hayabusa 2. Most recently, I've been involved with the OSIRIS-REx, which just came back, and several other missions currently and moving into the future. So in some sense, being on the science side, I'm the end user of the technology, and in some ways we can recognize what technologies we may need in order to advance our scientific exploration focus. I'm also maybe looking a little bit beyond the moon, because I'm interested in the solar system dynamics, and the primitive bodies that are in the solar system. So hopefully that can also provide an interesting perspective. One of the interesting things that I want to at least point out is the scale of these missions that we fly, that NASA has flown, can be immense. If you take the next slide. So the OSIRIS-REx mission was a mission that I was a co-I on, and it was incredibly successful, and it remains incredibly successful because the samples need to be analyzed over the next few years, and the satellite gets to be repurposed. This is a huge mission, probably the largest asteroid-focused mission to date that at least NASA has supported. 50 science co-Is. It started its phase B at least 12 years ago, development 15, 18 years ago, and it's still going. So this is one example, especially of a type of mission that NASA does extremely well at, but it requires a lot of support across the board. Infrastructure that is existing, that we're tapping into, and developing new ideas and new capabilities. Just to show a couple eye charts, this is the project organization, and the next one is the science co-I, list of co-Is. So it's a cast of literally thousands when you start adding up all of the people. So that's been an exhilarating experience to be involved with OSIRIS-REx. Let's go to the next slide. I've also been involved at the other end of the spectrum, and I was PI of the Janus mission, one of the NASA Simplex missions, where our costs are capped at $50 to $55 million. Very small satellites, but we have very large scientific goals that we carry out. And this is just an artist's rendition of what the Janus spacecraft were designed to do, which was to fly by some binary asteroids in the solar system. So this is a very different scale of mission, and it's a rideshare mission. So we don't control the launch. So we were originally scheduled to go with NASA's Psyche. With the delay, we were pulled off, so the spacecraft are actually waiting for their next adventure still. However, at the smaller scale, if you take the next slide, we see the mission organization is order of magnitude, maybe 2 orders of magnitude smaller, especially in how we run the mission. I was the PI. We had a handful of science team co-Is. We had a couple very competent and well-designed instruments supplied by Malin Space Science. And it was very much streamlined. So looking at these two ends of the spectrum, you really start to understand when you have a very expensive mission, you have to invest to have high guarantees across the board. When you have these very small focused missions, you can actually tolerate a lot more risk, and that actually opens up a lot of ideas for technology development. So that's my intro.
Thank you, Dan. And for the next, we have a video. Ramon Blanco is the U.S. head of space at Added Value Systems, AVS, leading the strategic expansion of its space division from Europe into the U.S. market. Do we have the video?
So that was a nice way to start and save me a few words. But I'll do a very quick story about my introduction to the space industry. I think my love for space came in fairly late compared probably to most people in this industry. I didn't really think about dedicating my life to space until my last year of university, doing aerospace engineering. In fact, my goal in studying that was improving the way we travel point to point on Earth, just making planes faster. That was my big challenge when I started. But there was this one mission at the end of my university called Inspiration Mars. That was one of the first times that competition ran by the Mars Society. And that provided for me a new experience that I hadn't had through my years of university, focusing more on aircraft engineering. The opportunity to solve some of the hardest problems, one of the biggest challenges, almost starting from scratch. There was no really an architecture that was established as the good way to do it, and even further, this competition was expected to orientate potentially a real mission to attempt to bring for first time 2 astronauts on a flyby mission around Mars. So that ability to really solve problems from scratch, innovate, and the fact that pretty much the space frontier was open for new solutions to be provided, that got me to not look back. From that moment, I went on to work at a startup trying to solve one of the biggest problems that I discovered during that competition, which was launch. We needed bigger launchers. This was, think around 2012, 2013. A couple of big launchers were planned for development, but still it was a very big challenge to get a human mission to Mars. So went on to try to do that for a couple of years in a startup. Eventually I joined one of the big prime contractors, Thales Alenia Space, where I saw a little bit more the reality of the industry, had the opportunity to work on a broad range of missions from telecommunications, Earth observation, interplanetary, some of the biggest geosatellite programs and constellations. And finally, I landed where what I consider today my home, ABS, Added Value Solutions, finding a very close connection with their mission, which is boosting scientific knowledge. And that was a surprise to find a commercial company, private company with that mission. And the more I knew about it, it just convinced me that's what I wanted to spend the rest of my career. And some of the great things that ABS has achieved over the years, trying to do just that, trying to solve some of the most difficult problems for larger companies, for agencies, and supporting that goal to boost really exploration, scientific knowledge through engineering solutions. I think what we're seeing in the current times with the growth of commercialization and what is being denominated as new space is providing the tools for more and more companies to dream big and to try to think about how to solve some of the biggest problems that before that thought was only limited to some of the larger companies, perhaps universities and agencies. But right now, we are able to have more minds thinking how to solve the biggest problems for humanity. And I think that's going to yield faster solutions, most effective solutions, and we will hopefully be able to do more and more as we go in the next years of space exploration.
Thank you, Ramon. So AC, I'll come to you first. So NASA is investing a tremendous amount into infrastructure. It's going to enable new ways of doing exploration, commerce. Can you give us a little bit of an insight into what NASA is planning and the infrastructure is preparing to build?
Yeah, thanks. If you were here at the last panel, Jim Free from NASA had a QR code, nasa.gov/architecture. And I'd encourage folks to go to that website where we have, I think, for the first time in many decades, as we've been looking at exploration, put out our plans and thinking and strategy publicly. The Australian Space Agency today just showed a slide, thank you, of using our Moon to Mars objectives and mapping what they're doing to the objectives and the principles that we put out in that document. And we did that exactly for this reason, as you just so gratefully showed, is we want to share with our partners how we're thinking about going back to the moon, the primary reasons, the decomposed objectives, the plans, and where can you all fit in, right? That's why that QR code exists. That's why that website exists. And I'm particularly interested in one particular segment, as we call it, of our Artemis plan. So if you open that document, we lay out the next few decades in various segments of exploration. Jim Free in the last panel had a human lunar return segment. Those are the initial Artemis missions. There's another segment of exploration we call it sustained lunar evolution, and I'm very keen on that piece of our lunar exploration campaign that goes to services. I think that campaign is, we have the ability to land on the surface for 6.5 days. Maybe we now extending that to 30 days. What are the additional services to enrich those kinds of exploration missions? And we have put out there various contracts for services ranging from crewed lander systems to spacesuits to lunar terrain vehicles. Now we're looking at cislunar commercial communications and position navigation timing, and there could be more in the future as well. And I'm very encouraged by not only the various pieces from transportation to suits to mobility to cislunar comms, PNT, but the way we're going about it, both in terms of tech development, where our Space Technology Mission Directorate is maturing technologies and innovative contracts that then we can infuse into these programs for particular exploration campaigns or segments to enable longer missions. So going from 6.5 days to 30 days to maybe even longer, what do we need on the services we need for to hit that sustained lunar evolution segment of our exploration campaign.
Excellent. And of course, Australia has a wonderful history of supporting space infrastructure going back to the Apollo program. What plans does Australia have to support this infrastructure in the future?
Lots of vision and ambition for that as well. And you're right, some of the video tracks and audio tracks of this lunar landing back in the days passed through some Australian ground station. As you know, in Canberra, we are hosting a couple of antennas for the Deep Space Network for NASA JPL. These antennas are operated and maintained by our colleagues at CSIRO, and they are participating in upgrading these antennas. We also host a few antennas from the ESA S-Track ground network in New Norcia in Western Australia. We have actually co-funded the development of their third antenna there, ground station, and NO3. So communication on the ground is very important to us. We have a location looking at southern sky, which makes us critical in any network for communication in deep space. And without communication, there is no space mission. It's just as simple as that. So we understand how critical communication infrastructure is. We are funding the development of 2 optical ground stations. We have blue sky, so this is good to do optical communication, but we need more than 2. So we have one in Western Australia, developed by University of Western Australia. Their expertise is in how to cater with the atmospheric distortion that challenge the optical communication. And we have another one developed by the Australian National University, ANU, in Canberra. Their expertise is around adaptive optics. So we are very lucky to fund 2 optical stations like that across 2 very cutting-edge disciplines. But 2 is not enough. We have blue sky, but we also have bushfires. So we have that vision of developing an Australian optical ground station network, so we can reach this 99.9% of reliability. So that's for comms, but in terms of infrastructure, we're also developing mission control that are specifically focused on remote operation for space exploration. So we have co-founded a facility in Western Australia with Fugro, and I believe that will be the first dedicated remote operation center in the world. And we are also looking into bringing more facilities to do radiation testing, because LEO is something, but the moon, around the moon and beyond, radiation is harsh, and I think we don't have enough facilities to test single event effect, gamma, X-ray. For a certain size, often you have facilities that can just bombard a small area of equipment. So we sponsored a few activities to have an area of the size of a PCB, so you can have some interesting results. We also have a lot of analog sites in Australia that we are promoting, but these are the kind of main infrastructure work we are currently doing, and our role in the agency is to promote this infrastructure to the world. So very happy to be there to promote these capabilities that we have.
Thank you, Anne. So Dan, in your introduction, you did a wonderful job explaining how universities are really at the edge of science and leading exploration, new instrumentation, miniaturization of systems. Can you help us understand from a university perspective how infrastructure will advance your ability and other universities' ability to engage in space exploration and science so we can understand our solar system better?
Yeah, thanks, David, for the question. As you mentioned, universities are really where most of the ideas that become reality initially are born, right? Of course, we need to, first of all, go from the laboratory into the technology and industry infrastructure, which can take some of these great ideas and either through a spin-off company or through investment, bring them into the space infrastructure, which I think is all the industry, the government labs, and the like. So that's sort of the stepping, that's the most important first step in the infrastructure. And then as we tile the Earth-Moon system, as we develop, the communication stations and systems, as we figure out how to use and implement new communications and propulsion technologies, I think what that does is it opens the door for the universities to start to develop lower cost solutions, innovative solutions to carrying out certain scientific missions, where we can leverage the investments that have been made by the national space agencies and also by the larger companies, and that really allows us to ride on the coattails of these investments. We could go through a long list of different investments that have been made that enable a lot of the interesting science that we can conceive of now, that we can design space missions for. I'm not sure if that, coming up with lists is what our goal is here, but I will certainly attest to the fact that the more infrastructure that exists, especially communications infrastructure, navigation infrastructure, in cislunar space and even beyond, the more we can design low-cost, innovative space vehicles that can tap into all of this.
Very good, thank you, Dan. So Ramon, you represent industry, and so from your perspective, how will these investments in lunar infrastructure create new opportunities for commerce?
Yeah, thank you for the question. So it just provides a win-win relationship. I think a very clear one. The government gets to access some of the most innovative and cost-effective solutions from the industry, and the industry gets the chance to innovate and create those solutions, and also for new companies to demonstrate themselves solving some of the hardest problems. So historically, government has been the spear of innovation for the space industry. Nobody has a doubt of that. But in parallel, we've seen how capitalism, commercial companies, and competition has been an environment where technology has evolved at a faster pace than ever before. So I think these new models that are being proposed and are already in place in some cases right now are pretty much taking the best of each side. They create the drive from the government to go and solve some of these largest challenges for the humanity, which would be quite risky to take on by themselves for commercial companies. But they don't tell them exactly how to do it. So they allow an environment in which the commercial companies are able to innovate to their full potential, and the way these contracts are set, it also promotes that they do that trying to achieve the lowest cost, so that they don't only do the mission once, but they achieve a sustainable business. And I think that is the key. That is the vehicle, so that we don't just go once to the moon as a great achievement, but actually we go, we stay, and we find out new business models, and we really have the chance to finally go to the next frontier of space exploration, not just the moon, but into deeper space, with the potential to create the largest value that has ever been created. At the end of the day, we have some limitations of resources on the Earth. There is no such limitations as we build the capabilities to be able to access everything we have in the solar system.
Yeah, thank you very much. So I'm going to go to the audience and have an excellent question for any of the panelists that would like to field it. How can we ensure that aspiring space nations can benefit from such infrastructure that they otherwise may not have access to? Yeah. Anybody that wants it? And aspiring nations, yes. Emerging spacefaring countries.
Sorry, it's very echo here. So emerging space agencies and emerging countries, so where we are in APAC, you've heard that there is the APRSAF conference, which is really dedicated to the Asia-Pacific regions. So we are getting more and more involved in this forum. We're also hosting the APRSAF in 2024. So that's a chance here to have a biggest role and focusing the agenda items that's going to be discussed there. We're doing already a lot with New Zealand. We also just launched a program with India, the International Space Initiative with India, where we encourage Australian companies to cooperate with Indian companies to deliver some projects. So this has been oversubscribed. I wish we had a bigger budget so we could fund more projects that we've received. And we are really having some very constructive discussions around the region. We're also trying to see how we can help inspiring our neighbor countries for STEM education. I was discussing with Jim Green yesterday about his metaverse school that he's doing. I think this is I think tomorrow morning he has a talk along this, and I invite everybody to listen to this because it looks fantastic, and that would allow a lot of people who don't have the chance to get exposed to everything that space can bring, and get inspired and start envisaging some career in STEM. And maybe the last thing I will mention, we've done with NASA JPL the first round of sending some First Nation students to do an internship in NASA JPL for 10 weeks. So they are actually over there. And that's important for us to be able to open the door that we have through the relationship we have with other agencies, so that our neighboring countries, but also our First Nation students can take opportunities like this. So we're doing good.
Thank you, Ann.
All right, maybe I'll add two things. One is provide your voice to agencies like ours, including at NASA. And we've given you, I think I commend our current NASA leadership for making sure we allow ways to get your voice heard by our teams, and specifically our architecture teams. If you want to influence infrastructure, the architecture, we have provided you a mechanism. We call that the Architecture Concept Review, ACR process, where there's our website I mentioned, nasa.gov/architecture, where we are asking for your input. We are releasing documents on that website, and I will tell you from the inside, NASA senior leaders like Jim Free take this very seriously. We are putting these documents out there. We're hosting workshops with international communities, other government agencies, commercial industry to get their voice and input into our architecture process. And every year we're committed to hear your voice, to solicit your input, to incorporate that input into our architecture plans, and that's one thing I would mention. And the other thing is to the point of how do we explore more sustainably, more ethically, and actually our office about a few weeks ago released a report on ethical and sustainability implications of our exploration campaign. And so I think that's also very unique in this way of how we're going back to the moon, is we're trying to solicit voices from different organizations. That actual report was a synthesis of a workshop we had where we invited First Nations and others to provide us input into what we're doing at NASA. And we look forward to doing more of that listening in terms of the different voices that are out there in our community to help inform our architectural decisions, which I think is kind of a cool thing beyond just the technical analysis. We're looking at the stakeholder community because that's ultimately one of the reasons why we're doing all this. So.
Very good.
Yeah, I want to point out a slightly different aspect about the infrastructure. And there is a huge infrastructure that's been invested into by NASA, by ESA, by all the spacefaring nations that we don't always recognize. And one example would be the Gaia starbase that was recently estimated, where we have these stars now estimated very precisely in the sky. That was an investment that improves our ability to do so many other tasks in space in terms of accurate navigation, in terms of identifying characteristics of targets and the like. Similarly, NASA's investments in the ephemeris, development is free to everyone, and all nations can take advantage of it. I think there are also some future investments that are being considered. I was just on a review panel for a lunar sensor network, creating like a GPS system at the moon. If something like that is developed, suddenly anyone that can get a spacecraft there at potentially lower cost can leverage this knowledge and do much more than they could otherwise.
Yeah, that's great. So I'd like to come back to something that AC started with, and Odd, I know you're very passionate about sustainability on the moon. If we think about what this portends, there are going to be many more players, some commercial, some scientific, some government. How do we maintain an environment, a lunar environment, that is sustainable?
I don't know. I think about that from the technology perspective and how technology can help in that question. And one of the things I think about are in-situ resource utilization, leveraging resources on the lunar surface in the Artemis context. But I also think about things like safe spaces, landing zones. When these landers, from some of the small landers from Astrobotic, Intuitive Machines, Firefly, and Draper, land on the lunar surface, they kick up plumes that could affect other spacecraft. And now we have much larger landers from SpaceX and Blue Origin that will have an even larger effect in terms of the plumes. So this is a problem in terms of how we land on the moon, because we're landing multiple times over the next decade. So one of the things I think about are, let's say, landing pads. We have recently invested over $10 million in a tipping point contract from our Space Technology Mission Directorate with Redwire. And that contract will look at technologies that could include developing landing pads. And if we had landing pads, all these landers will be landing, and the effects of them to the lunar environment, to other activities on the lunar surface will be substantially reduced. So that's a way of how a technology investment in terms of landing pads can help actually impact better exploration, and I would say more sustainable exploration. So that's one of the ways I think linking technology investment to this more amorphous metric of sustainability or ethical exploration kind of can be matched. So that's one of the ways I think about it.
Very good. If we can continue this, how do we keep the lunar environment sustainable?
I'm very happy you're asking this question because that's probably the first thing we started to think about 5 years ago when the agency was created. One of our pillars is to be responsible. And I could talk about sustainability for hours, but I'm going to try to keep it short. So we're looking at sustainability, and we're developing a blueprint around this. Sustainability is on Earth, how we can use space to help being sustainable on Earth, using PNT, EU, and other applications. How can we be sustainable in orbit, looking at collision avoidance, making sure that you have a plan for end of life of your satellites, and then sustainability on the moon, around the moon, and beyond. And I have to say, yesterday I listened to a couple of panels here, and they all mentioned sustainability, and I'm very glad because 5 years ago, nobody wanted to talk about it. When you look at the previous session, there was a map of the moon showing all the CLEPS missions and where they're going to go. Part of me is super excited, but part of me is like, what's going to happen to all these landers and rovers at end of life? And really that freaks me out. So we are designing our rover now, and we are thinking, what can we do right now to try to be sustainable or to try to apply some best practice, because you have to think about that at design level, not later. And that opened a lot of very interesting discussion that we're having with our two consortia who are currently doing the design of this rover. We're having conversation with the European Commission, who is looking at circular economy. What does that mean? And you know, they're telling us, if you share the bill of material of your rover and highlighting the material that could be reused at some point, publish that, making sure that we can access this system or subsystem that are part of material that can be reused, so design them so they are easily dismantleable. But also try to be interoperable with other missions. So if a rover is in trouble, the other one can help him or help her, whatever you want to call it. So looking at all these things. Another one is maybe thinking, once my lander has done his mission, can it be part of a bigger infrastructure we are building? Like, can it be a relay for, I don't know, a wireless network that we are building? And all this conversation, we need to have them now, and we have to have them now all together. All these technical solutions that we're gonna have are going to inform policies and regulation that we're gonna do very soon, I hope, because before doing regulation policies, we need to show that there is a solution to address that and to be compliant with them. And maybe one last thing I would say, you may remember that sustainability was around LEO constellation first. We're not talking about lunar. But you may remember AIAA did a best practice guidelines, very small document. They did that with SpaceX, Auditorium, and OneWeb. And they shared very openly with everyone who wants to read the document what they've done to try to do constellation in a sustainable manner. And we're looking at doing something similar with all the lander and rover designer, manufacturer. What can we share together to do a similar booklet to share best practice with the rest of the world? And we need to have this conversation right now.
Yes, thank you, Aude. So we're running out of time. There's some wonderful questions from the audience, including one for Aude regarding the Australia's rover. Where will it land? I want to encourage you to come and find the panelists after this session. You can ask more questions there. Perhaps we can meet outside. But now we have just a moment or two left. In 30 seconds, from an industry perspective, Ramon, what are your final words? What would you like to share?
I think industry perspective is, this is the most exciting time to be part of the space industry. I think the vehicles that are provided by government, the ways in which they're encouraging us to do new things, bigger things, and the traction that provides to actually do sustainable commercial businesses. It is just the most exciting time in terms of the goals that we have to go back to the moon, to go beyond the moon, bring humans for first time to another planet, and all the tools that are provided by the advancement in technology. So let's just do it. We just need more of us. So let's encourage new generations to join this exciting industry, which is not just exciting now, but it has the potential to be really one of the largest and one of the biggest value creation that has happened in the history of humanity.
Yes, thank you, Ramon. And Dan, your final words. Any last words?
I just want to point out again what the universities can bring to this whole question of infrastructure and exploration. First of all, I know for a fact that everyone here has gone through a university. So we are the institutions that create the people that go on to be astronauts, be engineers, and the like. But I also think that we've played a huge role in innovation in terms of sensor developments, technique developments. And I think in the future, I think the universities have to learn how to collaborate with each other a little more effectively. In the US at least, and I think elsewhere, we often have the sort of the football mentality of which university is going to beat which university. And I don't think that's a pathway to real success. I think collaboration. And I know Arizona State and University of Colorado have been discussing this and trying to figure out ways to move forward, supporting each other, and then probably having a much larger impact in the future.
Very good. Thank you. All your last words.
Yeah, I forgot to invite you all to Sydney in IAC 2025. We're very, very excited about that. And guess what? The theme is about sustainability. So it's a sustainable space for a resilient Earth. We don't want to only talk about sustainability. We want to demonstrate some actions that you all have taken in whatever endeavor you're doing in space. And we really want to show that this is a problem we can all solve. So you have 2 years to think about how you can demonstrate that you are doing space in a sustainable manner. And we are looking forward to listen to what you have to propose. So we have a small booth. Please pass by and be ready, because it's going to be a great IAC.
Thank you. AC?
Yeah, I think in the theme of this talk, I will leave the audience with 2 things I am personally excited about. The next decade will be incredible. Let me give you 2 snapshots of why it's going to be incredible. We are investing at NASA in crewed lunar landers from SpaceX and Blue Origin. And I do not think the public, domestically and internationally, knows the advanced technologies that are in those 2 landers. Those are both single-stage landers, different than Apollo in terms of the architecture, that both rely on cryogenic fluid management, that essentially are propellant depot-based crewed lander architectures. So that is the investment we're making in partnership with these 2 companies that will be enabled, and that will create incredible opportunities to leverage that technology. The other investment NASA is making with industry, and once again, a public-private partnership, is we are maturing with Nokia Bell Labs in the United States a 4G LTE lunar surface comms network. If you want 4K video from an astronaut 4.5 kilometers away to the lunar lander that they came from, you're going to need a high bandwidth link. And we're leveraging the terrestrial investments in 4G LTE with Nokia to demonstrate that. And we're about to demonstrate that on an uncrewed lander with intuitive machines. And so once again, these public-private partnerships are enabling massive changes in architectures and massive changes in technologies to enable capabilities I don't think we would have imagined in the 1960s. So it's going to be an incredible decade with these partnerships.
Well said, and great parting words. So please join me in thanking the panelists.